Hi everyone, today we're going to learn how to make Bohr diagrams. So the first element we're going to try as an example is lithium, which has the symbol Li. If we look on our periodic table, lithium is up in the top left corner. It has atomic number 3, and it has an atomic mass of 6.941 AMU. That's the unit we would use to talk about atomic mass. So on the board, I'm going to write what we have. Its number is 3, and its mass is 6.941. That's all we need off the periodic table for this. Now for a Bohr diagram, we need to know 3 things. We need to know how many protons, we need to know how many neutrons, we need to know how many electrons are in a typical lithium atom. So P, E, and N, proton, electron, and neutron. Now for protons, it's easy. The atomic number is always the same as the number of protons. If we had atomic number 4, we wouldn't have lithium anymore. We would have the next element up, which is beryllium. If we had one less, we would have the element before that, which is helium. If we have lithium, lithium is atomic number 3, we know we have 3 protons always. Electrons is also very easy, because when you're doing a diagram, you know you're making a neutral atom. Neutral means protons and electrons are balanced. Protons are positively charged, electrons are negatively charged. So if they're balanced, that means we need to have 3 electrons if we have 3 protons. So protons and electrons are both going to be the same as the atomic number in a Bohr diagram. Neutrons are the ones that trip people up, because neutrons could be any number. They might be 3, they might be 4, they might be 5, they might be 2, they could be anything. With neutrons, you actually have to calculate. Now your number of neutrons is always going to be your atomic mass that you got off the periodic table minus your atomic number. The reason for this is because the atomic mass is your number of protons plus your number of neutrons. Electrons doesn't factor into it because they weigh so little. So if you got mass by adding protons and neutrons, then to get neutrons back, you're just going to take away your protons, which is the same thing as your atomic number. So in this case, we've got N equals 6.941 as our mass. We're going to subtract 3 as our atomic number, or our number of protons. And that will give us 3.941 as our result. Now we can't have 3.941 neutrons. We can only have 3 neutrons or 4 neutrons, because a neutron is a specific discrete object. You can't have a partial neutron. Now the reason that the mass on the periodic table was a decimal is because sometimes lithium atoms will have 3 neutrons and sometimes they'll have 4. These are called isotopes of lithium. It's the same element, but it has different numbers of neutrons. But when we're doing a Bohr diagram, we're typically looking for the most common type of atom. So we're just going to round this to the nearest whole number, and that will get us the number of neutrons in the most common isotope of lithium. So the closest whole number to 3.941 is going to be 4. Right? We can either round it up to 4 or down to 3. 3.941 is way closer to 4. So we're going to round that up to 4, which means our number of neutrons is 4. Now we have protons, electrons, and neutrons, so we have everything we need to draw the Bohr diagram. Now with the Bohr diagram, we're going to start with a circle in the middle. This is the nucleus. That's the center of the atom where the protons and neutrons are found. We have 3 protons and 4 neutrons. So we're going to write P equals 3 and N equals 4. That's the protons and neutrons. We also have to put electrons, but electrons are not in the nucleus. Electrons are in what some people call orbitals, what some people call shells. They're basically rings extending out from this nucleus, and they're orbiting, or they're spinning or buzzing around this nucleus at very high speeds. Now the first orbital, or the first shell, can always hold only 2 electrons. 2 electrons and it's full. We have 3 electrons to deal with in lithium. So the first 2 are going to go in the first shell. You always fill electrons from the inside out. So I'm putting 2 dots on this first shell to show that Lithium has 2 electrons in the first shell. Now the first shell is full. We can't put anything extra in it because it's already got 2. The next shell up from that can hold a maximum of 8 electrons. So I'm going to add another shell because we still have electrons to deal with. We have 3. We've only put 2 on. And that means we have 1 more to give. Because we need 3 electrons. We've put 2 in the first ring. We're going to put a third on this outer shell. Now our outer shell has 1 electron. Our inner shell has 2 electrons. We've included all of our 3 electrons. This is our completed Bohr diagram for lithium. Now let's do another example. Silicon, which has the symbol Si. Not S, S is sulfur. So if we look at our periodic table, silicon is right near the middle of the right side. It's got atomic number 14, and it's got mass 28.09, and that's going to be in the unit AMU, remember, atomic mass unit. So number 14 with a mass of 28.09. And I'm not going to bother writing AMU here, but it's in AMU. Now remember, for a Bohr diagram, we need 3 things. We need the number of protons, the number of electrons, and the number of neutrons. So I'm going to write P, E, and N over here. Now the number of protons is easy. It's the same thing as the atomic number. The atomic number is always the number of protons. So we have 14 protons in a silicon atom. The electrons is going to be the same as that, because when we're doing diagrams, we're always doing diagrams of neutral atoms. Neutral means the electrons cancel out the protons. So we're going to have 14 electrons as well. Same number here. All comes from the atomic number. The neutrons is the different one. Neutrons might be 14, but it might be something else. You've got to calculate it. Now remember, the formula for neutrons is going to be your mass from the periodic table minus your atomic number. So in this case, we're going to have neutrons is equal to the mass 28.09 minus the number 14. And that's going to get us an answer of 14.09. Now remember, you can't have 14.09 neutrons. You can only have 14 neutrons or 15 neutrons. It's got to be a whole number. 14.09 is much closer to 14 than it is to 15, so we're going to round this to 14 neutrons. And remember, the reason you have to round this is because you've got a decimal for mass, because the mass value on the periodic table is an average of all the isotopes of silicon in nature. There's multiple isotopes of silicon. Not all of them have 14 neutrons, but the isotope with 14 neutrons is most common. And that's why we rounded to it. So we're going to put 14 for N. It happens to all be 14s, but you can't guess that. You always have to calculate it. Now that we have protons, electrons, and neutrons, we can do the diagram. So to start with, I'm going to do a small circle, and that's the nucleus. That's the center of the atom. In the nucleus, we have our protons and our neutrons. So I'm going to write P equals 14 and N equals 14. Now we still have our electrons to put. And electrons are not in the nucleus. They're in what are called the orbitals or the shells, and they're orbiting around that nucleus. So in the first shell, we can fit 2 electrons, only 2. We have 14 to work with, but we can only put 2 in that first shell. So 1, 2. And some teachers like you to pair these electrons up. I don't really care about that. And I'll show you what I mean by that on this one. The second shell can always fit 8 electrons total. That's what we call the octet rule. Remember, octo means 8. So we already used 2 of them. We can easily put down another 8, because that'll only get us to 10 electrons spent already. So if I do it in pairs, like some teachers like, I would do 1, 2, 3, 4, 5, 6, 7, 8 electrons in that second shell. Now we have 10 electrons on the board. We need to do 14 electrons though. This second shell could only hold 8, so it's full. we're going to add a third shell outside. And if we were filling it, this third shell could hold 8 as well. But we're not going to get to that point because we only have 4 more electrons to work with. So I'm just going to put that remaining 4 in that outer shell. 1, 2, 3, 4. And that's our completed structure. So we've got the protons and neutrons in the nucleus, and we've got the electrons in the orbitals like that.